So this is an introduction on the elimination method used to solve a system of equations. So just to recap, a system of equations is when you're dealing with two or more equations at one time. If we're looking at a graph, it would be where your graphs would intersect. So you're looking for the point or points that your graphs or equations have in common. So we've looked at graphing before, we have done substitution, and elimination is the last and final method that you can use, at least that we're going to do in Algebra 1. So basically what elimination does is it temporarily eliminates one of the variables to make your equations easier to solve. So sometimes this is called the knockout method, the crossout method. Basically what we're going to be looking for is we want to have opposites that would get either the x's to cross out or the y's to cross out when we're dealing with these problems. So the setup is a little different than when we are dealing with graphing and when we are dealing with substitution. For elimination, the problems look a little different. They have everything lined up nicely in rows. So the x's are lined up together, the y's are lined up together, our equals, and our answer part. So these are two that we're going to look at today. These two examples are pretty straightforward. Nothing super crazy here. You can really use either addition or subtraction to solve these. I tend to like using addition for these, but I'm going to show you both ways just so that way you see them. And it kind of depends on what the problems look like. Next week, we're going to start to look at some that are a little bit more involved, where we're going to have to manipulate one or both of the equations in order to get something to eliminate. So the directions are here if you want to come back to it or screenshot it or jot a couple of these down. If you happen to have your system of equation note pack at home with you, this is from that. I don't remember what page it is, but that's where I took this information from. So it is in that packet. Okay, and we'll kind of go through some of these steps as we go through. So if we look at number 1, this actually is set up that you could do a couple operations to get things to eliminate. So right now I have x minus y equals 1 and x plus y equals 3. So you could use either addition or subtraction for this problem. I'm going to show you guys addition for this one just so that way you see. So what that's talking about, since everything's nice and lined up in these columns, that usually tells me that I want to at least try and look and see if elimination might be nice. And then I'm going to add my two equations together. What I've just got to be careful with, these don't have coefficients written in, so right now I know that there's a bunch of 1s. Just to make my life easier, I'm going to write those in. Well, 1x plus 1x, I know that from solving equations, 1x plus 1x gives me 2x. Now here, negative 1y plus 1y. Well, those are opposites of each other. Negative 1 plus positive 1, that's going to equal 0. That's going to eliminate my y's from my problems. If you want to write in plus 0y, you can write that in to help you out. Okay, the last thing that we also have to remember here, though, and this is the one that people tend to forget when they're solving problems by elimination, is you also have to add the answer parts together. 1 plus 3 gives me 4. Well, I don't usually write in the 0y, but if it helps you, you can. I don't really need this in here. 0 times y is just 0. So this is really, this whole thing is saying 2x. So 2x is equal to 4. Well, I can very easily figure out what x is right now by just dividing both sides by 2. 4 divided by 2 is going to leave me with 2. Well, I know from solving systems of equations with my other methods is that usually I'm not just looking for an x and a y, but in fact I'm looking for both variables. So I still need to find that other variable. So I'm going to use my x equals 2, and I'm going to substitute it into one of my equations. For this one, I'm going to actually pick this bottom equation only because there's no negatives in there, so I don't have to worry too much about my signs. So I'm going to use this x plus y equals 3. So I know that x is 2, so I'm going to put my 2 in for my x. And now I'm looking for my y. So this is a simple equation now. This is attached by addition. To undo addition, I'm going to subtract 2 from both sides. 3 minus 2 leaves me with 1. So when my x is 2, my y is 1. And if I want to write this as a point, sometimes that's how we're asked to write things, our solution for this problem would be 2, 1. We always put those x coordinates before the y's when we're talking about a point. Now, number 2, this one here is a little bit different. We got a few more numbers, coefficients going on in front of our x's and our y's, but it's not too bad when we're looking at this. So we've got 3x plus 4y equals 19 is our top equation. 3x plus 6y equals 33 is our second equation. So looking at these, if I right now were to try and add them together and start this off like I did in my last problem, 3x plus 3x gives me 6x, 4y plus 6y gives me 10y, and nothing canceled out. Okay, so addition is not going to work for this. So I'm going to erase what I just did. Hopefully. Maybe. There we go. Okay. Now my eraser doesn't want to go away. Okay, so addition doesn't work. So we've got to do this a different way. So we can also look at subtraction. Okay, and subtraction is another way that I can get things to cancel out. 3x minus 3x. Well, 3x minus 3x, 3 minus 3 gives me 0. So that's going to eliminate my x's. What I have got to be so careful with now, even though my x is already eliminated, I have to make sure I subtract everything else. 4 minus 6y. 4 minus 6 leaves me with negative 2y equals 19 minus 33. So I have to be careful with these signs. And I'm just getting my calculator out here because it is late while I'm filming this. Okay, so 19 minus 33 leaves me with negative 14. Okay, to get y alone, we've got to get rid of this negative 2, so we're going to divide it on both sides of our equation. Negative 14 divided by negative 2 leaves us with a positive 7. So we're not done though. Just like in the last problem, we've got to find our x. So these ones, neither one look all that much easier than the other, so I'm just going to pick my top equation here. So I've got 3x plus 4y is equal to 19. So I know, since we just solved it, that y has to be 7. And now I've got something to solve. So before I start moving things around, I've got to figure out what 4 times 7 is, which happens to be 28. So to get x alone, I'm going to subtract my 28 from both sides of my equal sign. I have a two-step equation now. 3x is equal to 19 minus 28 leaves me with negative 9. Divide both sides by 3. Negative 9 divided by 3 is negative 3. So now I have my pair of variables. I have an x, I have a y, and I can write my solution as an ordered pair. Okay, so no matter which order you solved your variables in, if you found x first or you found y first, it doesn't matter. When you're writing your solution, the x coordinate always goes first. So it would be -3, 7. Next week, we're going to pick up a little bit more with elimination, where we're going to have to start manipulating our equations a little bit. But this is just kind of giving us that introduction on how to solve these equations.